August 2025, the James Webb Space Telescope captures data that shouldn't exist. An interstellar comet moving faster than anything we've ever seen is now acting less like a frozen ball of ice and more like a probe on a mission. This isn't science fiction. This is 3/I, only the third visitor from beyond our solar system. But unlike the previous two, this object is breaking every rule we thought we knew about interstellar visitors. Harvard's Avi Loeb has already suggested 3I/Atlas may not be a random visitor. Its trajectory seems almost scripted. Its chemistry defies explanation. And its speed, it's moving with an urgency that has scientists asking uncomfortable questions. The evidence is mounting, and what they're finding is forcing us to confront a possibility we never wanted to consider. When Webb and SphereX turned their instruments toward 3I/Atlas, they expected to see what every comet shows: water vapor dominating the spectral readings. Water is the universal signature of comets throughout our solar system. Instead, they found something that made mission teams double-check their calibrations. The CO2-H2O ratio measured 8:1, 8 parts carbon dioxide to 1 part water. This is one of the highest ratios ever recorded in any comet anywhere. To put this in perspective, normal comets from our own solar system show the opposite pattern. Water dominates, ice melts first as objects approach the sun. But 3I/Atlas is venting massive amounts of carbon dioxide while barely releasing any water vapor at all. It's as if the object is venting in a way designed to confuse us. Carbon dioxide creates thick opaque clouds that hide whatever lies beneath. If something wanted to mask its true nature, this would be the perfect camouflage. But the chemistry was just the beginning. 3I/Atlas shattered another record that left astronomers speechless. This object is moving at 130,000 miles per hour. That's the fastest speed ever recorded for any visitor to our solar system. To give you perspective on just how extreme this is, 130,000 miles per hour means 3I/Atlas could circle Earth in just 11 minutes. Most interstellar objects drift through space at speeds that reflect their billion-year journeys between stars. They coast, they tumble, they follow predictable physics. But 3I/Atlas isn't coasting, it's racing through space with a velocity that suggests intention. Why would a natural object be moving with this much urgency? What could accelerate a chunk of ice and rock to these incredible speeds? The numbers don't add up for random debris from a distant star system. Think about it, a rock from another star system blasting through at 130,000 miles per hour with chemistry no one expected. The CO2 is drowning out every other signal, creating the perfect smoke screen around whatever's actually inside that coma. Is this just coincidence? Two impossible anomalies in one object? Or is this the signature of something more deliberate? Something that doesn't want to be studied too closely? Before we go deeper into what scientists are really finding, what do you think? Are we looking at the most unusual comet ever discovered or something else entirely? Let us know in the comments before we reveal what's really happening. And these weren't the only signs. Its very path through space told a bigger story, one that has astronomers questioning everything they thought they knew about random visitors from the stars. But the speed and chemistry anomalies were just the beginning. When astronomers plotted 3I/Atlas's exact path through our solar system, they discovered something that made them pause. This interstellar visitor isn't tumbling through space at some random angle. It's traveling along a trajectory that's tilted only 5 degrees from the ecliptic plane. That's the invisible disk where almost every planet in our solar system orbits. Most objects from interstellar space arrive at steep, chaotic angles. They barrel in from above or below, following paths that reflect their billion-year journeys through the galaxy. But 3I/Atlas is staying right in the sweet spot where all the action happens. And the route it's taking reads like a planetary tour guide. Venus first at a distance of just 0.65 astronomical units, then Mars at 0.19 astronomical units, and finally Jupiter at 0.36 astronomical units. Each flyby perfectly positioned for maximum gravitational assistance. And if you were a probe, maximum data collection. Random chance or a pre-planned tour of our system's most important worlds. The mathematics are brutal. The odds of an interstellar object naturally arriving on such a perfect trajectory with such precise planetary encounters are astronomically small. It's like throwing a dart from another continent and hitting the bullseye. Avi Loeb noticed something else that sent chills through the astronomy community. The timing of 3I/Atlas's closest approach to the Sun isn't random either. Perihelion, the point where the comet will be brightest and most active, occurs on October 30, 2025. But here's what's unsettling. At that exact moment, Earth will be positioned on the completely opposite side of the Sun. As if the object is hiding behind the solar glare just when it matters most. If you were designing a reconnaissance mission, this is exactly how you'd plan it. Approach when the primary target can't observe you directly. Use the sun's overwhelming brightness as a shield. Conduct your most critical operations in the shadows. Loeb puts it bluntly, this could be intentional to avoid detailed observations. The timing is so precise, so perfectly orchestrated, that coincidence starts to feel like wishful thinking. Harvard's warning was simple. 3I/Atlas is acting like a probe. The chemistry is wrong. The speed is impossible. The trajectory is too perfect. And the timing suggests deliberate concealment. And the next anomaly only deepened the suspicion. Let's slow this down. If you were sending a spacecraft to study an alien solar system, where would you point it? You'd keep it close to the planetary plane where all the interesting worlds orbit. You'd plan flybys to gather maximum data. You'd use the host star's gravity for course corrections and energy boosts. That's exactly what 3I/Atlas is doing. It's following the textbook playbook for interplanetary exploration, hitting every major world in sequence, timing its closest approach for maximum concealment. Now maybe it's chance. Maybe we're looking at the most perfectly unlucky coincidence in astronomical history. But admit it, doesn't this sound a little too scripted? And the idea of scripting gets even stranger when we look back through history. This isn't the first time an interstellar visitor has shattered our assumptions. In 2017, Oumuamua arrived with its own set of impossible anomalies, unexplained acceleration that defied gravity, a shape so elongated it looked artificial, reflectivity patterns that suggested metal construction. The scientific establishment eventually explained away most of Oumuamua's strangeness. But the debate revealed something deeper, our terror of the unknown visitor from the stars. That fear runs deeper than modern astronomy. 5,000 years ago, Babylonian priests etched careful records of strange visitors in the night sky. They called them omens, harbingers of change that demanded royal attention and sacrifice. The ancient Egyptians went further. When meteors fell from the heavens, they didn't just observe. They collected the sky iron and forged it into sacred objects. Tutankhamun's ceremonial dagger was made from meteoritic metal. To them, anything from the stars carried divine power. Even in the modern era, our reaction hasn't changed. During the Cold War, early satellites crossing enemy skies sparked global paranoia. Every moving light became a potential spy. Every radio signal a possible invasion. The fear was primal. What if it isn't natural? 3I/Atlas triggers that same ancient response. The same questions our ancestors asked when strange lights moved across their skies. Every era feared sky visitors. Babylonian priests, Egyptian pharaohs, Cold War generals, all asked the same fundamental question when confronted with something they couldn't explain. Now 3I/Atlas is forcing us to ask that question again. Natural wanderer or probe from elsewhere? Here's the thing. This isn't the first time humanity's imagination has been set on fire by something in the sky. From priests in ancient Babylon tracking omens in the stars to generals during the Cold War wondering if every satellite was a weapon, the fear was always the same. What if it isn't natural? What if something is watching us? 3I/Atlas puts us right back in that same timeless question. Except this time, we have the technology to actually find out the truth. And that truth might be more unsettling than we ever imagined. But what if this visitor isn't just passing by? What if it has a plan? So what happens next? If 3I/Atlas really is more than just ice and rock, what could it actually do? Avi Loeb outlined 3 possibilities that have space agencies quietly running calculations. First, the Oberth maneuver at perihelion. In late October, when 3I/Atlas reaches its closest point to the Sun, any object with propulsion could fire engines for maximum effect. The Sun's gravity would amplify every ounce of thrust. Loeb calculated that even a small course correction at perihelion could drastically alter 3I/Atlas's trajectory. Instead of flying past and disappearing forever, it could drop into a new orbit, one that brings it much closer to Earth. The mathematics are terrifying. A controlled burn lasting just minutes could redirect this 130,000 miles per hour visitor toward our planet. Arrival time, late 2025 or early 2026. Second scenario, swarm release. What if 3I/Atlas isn't the probe itself, but the carrier? The dense carbon dioxide coma would be perfect cover for releasing dozens of smaller objects. Seed probes, each no bigger than a satellite, scattering toward different planets. This isn't wild speculation. Loeb's Galileo project is already monitoring Earth's skies for exactly this possibility. They're watching for any spike in unexplained aerial phenomena around the time 3I/Atlas passes perihelion. The third possibility chills astronomers most: the stealth craft theory. What if advanced civilizations use hollowed-out asteroids as camouflage? Natural rock shells hiding sophisticated technology inside. With 3I/Atlas's incredibly dense coma obscuring its core, we have no idea what's actually underneath all that carbon dioxide. The perfect smoke screen for something that doesn't want to be seen. If this was just ice and dust, we wouldn't be here. Normal comets don't break speed records. They don't follow perfect planetary tour routes. They don't time their brightest moments to hide behind the sun. But the possibility, however remote, of something engineered keeps scientists watching closely. And honestly, that's what makes this so terrifying and exciting. Okay, let's be clear. No one's saying aliens are definitely inside this thing. But the fact that respected Harvard astronomers are even testing the probe idea, that tells you how genuinely unusual 3I/Atlas really is. These aren't fringe theorists or conspiracy websites. This is Avi Loeb, director of the Galileo Project, publishing papers and calling for NASA missions to intercept this object. When mainstream science starts asking whether something might be artificial, you know the evidence is getting impossible to ignore. And honestly, that's what makes this so exciting. We're living through the first time in human history where we might actually be able to answer the ultimate question. So, what does it mean for us here on Earth? The implications of 3I/Atlas stretch far beyond astronomy textbooks. This single object could rewrite humanity's place in the universe. If it's natural, we're looking at chemistry that expands our understanding of how star systems form. Comets with 8:1 carbon dioxide ratios challenge everything we know about planetary accretion. The speed suggests stellar environments far more violent than we imagined. But if it's artificial, if even one component of 3I/Atlas shows signs of engineering, that's proof we are not alone. Not just microbial life in subsurface oceans, but technological civilization capable of interstellar travel. Either way, humanity is staring at something never before seen. Something that forces us to confront possibilities we've only dreamed about. The window for answers is closing fast. 3I/Atlas will disappear behind the sun in early October. When it emerges in late 2025, it might be too distant for detailed study. This could be our only chance. If you're still watching, you're exactly the kind of person we make these deep dives for. Subscribe and hit like because this story is just beginning. And trust me, you don't want to miss what happens next. Here's the bottom line. 3I/Atlas isn't just another rock drifting through space. It's faster than anything we've recorded. Its chemistry defies explanation. Its trajectory seems scripted, and it's timed in a way that feels impossible to ignore. Is it a frozen relic from a distant star system carrying exotic chemistry from alien worlds? Or is it the first probe we've ever detected from somewhere else? The first evidence that someone, somewhere, is watching us back? That's the question history will judge us by: how we respond to the first genuinely anomalous visitor from beyond our solar system. Maybe it's natural, maybe it's not. But the fact we're even asking this question proves one thing: the universe is watching us back. For those who want the technical details, 3I/Atlas was first spotted on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System telescope in Chile. It's officially the third interstellar object ever detected, following Oumuamua in 2017 and Comet Borisov in 2019. The object will reach perihelion on October 30, 2025, at approximately 1.4 astronomical units from the Sun. That's just inside Mars's orbital distance. Its closest approach to Earth will be around 1.6 astronomical units, roughly 150 million miles away. NASA confirms there is zero impact risk. Based on brightness measurements, astronomers estimate the solid nucleus is at most 3.5 miles wide, though it could be much smaller if the surface is dark. The massive coma of carbon dioxide and dust makes precise measurements difficult. Multiple observatories continue tracking 3I/Atlas through September 2025. After it passes behind the Sun, telescopes will have another opportunity to study it as it recedes in late 2025 and early 2026. The official word from NASA remains unchanged. 3I/Atlas behaves like a comet. It outgasses like a comet. It probably is a comet. But the anomalies keep the question alive. And that's why the world is watching.